and the tissues and the air passageways and stuff, and it's tough. It really is tough. We can treat symptoms, but we can't cure. Okay. We have several researchers at the University of Iowa in research that are working on this disorder. It's very common. It occurs 1 out of every 1,600 births, and people will say, well, that's not very many. I can assure you, students, there are 1,600 babies born in this country every day. Okay? That's not unbelievable at all, especially when you've been around this planet as long as I have. Okay? There are lots and lots of kids around. Okay? So, yep.
Isn't cystic fibrosis, doesn't that have something to do with dysentery? Or I remember reading in the text that maybe cystic fibrosis had a almost beneficial effect on people with some sort of disease in Europe where it didn't work against their body, it actually helped them.
Oh, I see. You may be thinking of sickle cell anemia.
Well, no, I know it said that helped against malaria, but it
Right.
said that, I thought it said cystic fibrosis helped against dysentery in Europe.
I've never read about that. Cystic fibrosis is a little more serious than sickle cell is. People live quite some time with sickle cell. Okay? But cystic fibrosis is, we would be hard pressed to find very many young people, young babies born with cystic fibrosis who would ever make it to high school. Okay? It's pretty debilitating, simply because there are too many pleiotropic effects. I mean, even if it did that, affect your digestive tract that bad, then it would, obviously, you wouldn't be able to metabolize food real well. So it would be, be tough. I'm not going to say that it wouldn't affect your digestive tract. I doubt that it would benefit you very much, right? Okay. Knowing what I know about the disorder, okay? Because it's very, very serious, okay? And many of these, of course, are, I always use the analogy of the dominoes. Many of them make the dominoes fall faster than other ones do, okay? And you may find that as you do a research project. Okay? Many of these are very debilitating, much more debilitating than others are. Okay? But these are the kinds of disorders that you hear some things about because of organizations like the March of Dimes and the various foundations that exist around the country that cater to these things and so forth. And I'll talk a little bit about some of those next week, because you might find those organizations to be great resources for your research, because they have a lot of information. Okay? So I just talked to a young person today from one of the other classes who wants to do research on breast cancer, and I said, well, you certainly won't have any problem finding information on that. It's been on television almost every day, so there's lots and lots of information. So there's lots and lots of information on many of these kinds of things. But one of the things that's sort of amazing about this, if you look at this first column of bases, there's a little triangle down there. They refer to it at the bottom in that paragraph. That's the position where the amino acid phenylalanine is no longer there. It's been deleted. That means the base pair sequence that would cause it to be there is gone. What caused it to be deleted, we don't know. I mean, we don't know why some of these things got deleted, why the mutation happened. Many mutations just happen spontaneously. They just do. We obviously know that if you stood in front of an X-ray machine every day, that wouldn't be healthy. Okay, that's why I always use this, because everybody's had one done. Everybody's been at the dentist, and you probably noticed that when you go get X-rays at the dentist, they lay this big lead apron across your body, don't they? All right. You know why they do that? A lot of people don't. A lot of people think maybe they're doing it because they don't want you to squirm around in the chair, or they don't want you to escape, No, they aren't doing it for that reason. They don't want those X-rays to hit your ovaries and testes. Think about what would happen. Well, you may not be in a position yet to say, well, I'm going to procreate children someday. Okay? But they're just saying, well, just in case you are going to do that someday, we want to give you a fair shot at it. Okay? And we'd like to have your children be normal. Okay? We don't want you to be zapped by X-rays every time you go to the dentist. Some people, I don't know about you, but I go at least twice a year. Okay? Of course, I'm done procreating kids, but I'm still not going to, I still don't really, want to have, expose my body to X radiation when I don't have to. So we take every precaution in the world, you know, that, you know, we purposely don't want to do that. Okay? So, you know, some things we know and some things we don't know, so we put science to work for us and we try to increase our understanding. So, but lots of people are kind of amazed. I find the students in class kind of amazed that here's a situation where there's just like one tiny little error, you know, and you would think, God, it wouldn't make that much difference. And yes, it does. Okay? This particular protein doesn't get made normally. It doesn't bend and fold in the right shape, and it can't move those ions across those cell membranes. So you're in deep trouble there. Okay? If you get two recessive forms of that gene, you got cystic fibrosis. Okay. None of you have it, by the way. If you did, you would be here. Okay? All right. So that's that sheet. That's that sheet. This one right here, I gave you a little dry lab experience again with taking some more DNA sequences and just follow the directions. Okay? Using the codon chart that you used to get your other one. By the way, you can read me the codon or the amino acid sequence for the ones that you did for today. Off your graph paper. Remember you had to go and get a codon chart out of chapter 17? Can you read me your sequence? From top to bottom? Tell me what you got. Then I'll let you do those other ones for some of your homework for Tuesday. In addition to finding your gene, and I'll tell you about two other little lab topics we're going to let you look at today in the lab. What's the sequence? Start with the first amino acid from the first three letters and read down. Who can do it? Who thinks they got them all off the codon chart? Who thinks they got them? Nobody? Oh my gracious, we have all kinds of volunteers in the other classes. Okay. Jenny, what'd you get? TRP. Okay. GLN. Okay. ARG. LEU. ARG. ARG. We okay, everybody? All right, that's the sequence. Okay. That's the sequence. Now that's not a protein, that's just practice, okay? There are some proteins that are short, but that's not one, okay? We just made that one up, okay? We just made that one up. All right. Here's two things I'd like for you to do in laboratory work today. We always want to do a little laboratory work before we kind of go home. I'd like for you to check your fast plant germination back there. Some of it isn't germinating very well, and I may want you to put some more seeds in there or change things a little bit. So I want you to go find your little styrofoam thing, bring it to me, and I may say, let's put some more seeds or not. We're going to do that. And then the stuff to do this DNA model thing is over there on the side counter. You can start that. Okay?